Unlike vitamins and macronutrients, which are organic compounds, minerals are elemental atoms or ions, and you can't break them down any further. These are pretty indestructible. They're not destroyed by heat or acidity. In fact, it's a part of the ash left behind once a food is burned. In fact, the residue in the bottom of such a pot was called pot ash, which gave way to potassium. And these are needed in relatively small amounts, and they're often grouped based on how much is needed in your diet. A mineral is considered a major mineral if we require greater than 100 milligrams per day. There's 7 of those. And trace minerals are required in lesser amounts, and there's 9 of those. There are actually some more. We just tend not to talk about them. Both major and trace minerals are very important and serve diverse functions in the body. In fact, individual minerals serve many functions. Plant and animal foods are sources of minerals as well as water. With animals, the proportion of minerals that you're getting are very similar to your own body composition, so it fits the need very well. And the amount of individual minerals in plants are extremely variable. They can be great sources, but variety is key to getting everything that you need. The soil it's grown in and the maturity of the plant play large roles as well in the amount of mineral content that it has. And lastly, water is a source of minerals. Since studies in the 1940s showed that fluoride has the ability to prevent cavities, it's been added to about 3/4 of the public water supplying U.S. citizens today. A key concept to understand is that just because we consume a mineral, or any nutrient for that matter, it doesn't mean that we are absorbing it into our system. Our GI tracts absorb a small percentage of minerals, and this could be modulated by several factors. And this is where recommendations can struggle to provide the true picture of what we really need. If we're low on a particular nutrient, say we're calcium deficient, our bodies will adjust to absorb more of it. If we have high levels of a few nutrients, it can overpower the absorption of others. And this can be due to competition for transporters. Calcium, iron, zinc, and magnesium, they share chemical properties with each other, and they end up competing with each other for absorption. You throw in fiber into the picture, and all 4 of them can struggle to be absorbed efficiently. There are also compounds like phytates found in whole grains and beans, and oxalates, an acid in leafy greens. And these bind to specific minerals and carry them out of the intestine completely unabsorbed. And collectively, the term bioavailability describes the ability for these nutrients to get across that intestinal border and into the bloodstream in order to be utilized by the body. I want to pay special attention to 2 major minerals, sodium and potassium. And they have known mechanisms for their roles in causing and preventing diseases, often opposing each other's actions, as in the case of hypertension. These are featured on the nutrition facts label as well, which makes us able to monitor our consumption of them. Be sure to watch the 2 videos on Canvas to get more on the backstory, but I'll briefly talk about them here. When you think about sodium, you think about salt. Now, table salt is sodium chloride, which means that it's about 40% sodium by weight. And you've heard of salt's ability to preserve items from spoiling, and throughout history, salt was prized as a prized commodity. Phrases like, "you're worth your salt," and the term salary come from the importance of this nutrient. However, with food processing and industry's desire to extend shelf lives and transport food all around the world, too much salt has been added. Of course, consumers like the taste of salt, and we should, it's a survival mechanism, but we're taking in way too much of it. In an NHANES survey of 15,000 people, 98% of men and 80% of women were consuming too much salt, and this peaks between the ages of 19 and 50. The recommendation is to take in less than 2,300 milligrams per day. And if you're at risk for heart disease, you have prehypertension or hypertension, you want to get that down to around 1,500 milligrams per day. And however, even the at-risk population was taking in too much. About 75% of them were over the 2,300 milligram threshold. So how do we cut down on the sodium? It's simple. We cut down on processed foods. It's estimated that about 70% of salt intake comes from processed foods. That estimate has since been raised to 75% by the Department of Health and Human Services. Fortunately, they're required to post their salt content. Unfortunately, the posting of salt content doesn't curb consumption enough. We're still consuming way more than we should be. This was one of my favorite studies when it came out. It was published in the New England Journal of Medicine, and it used some pretty advanced computer modeling to predict what would happen to rates of heart disease, stroke, heart attacks, and overall death if Americans would either consume less salt, a reduction of current intake of either 1, 2, or 3 grams, eliminate 50% of smoking, reduce the BMI of all obese individuals by 5%. They all lose weight. Or we give statin drugs to everyone in America. Those are the cholesterol-lowering medications like Lipitor. Or we give all hypertensive individuals medication to help with their high blood pressure. So what do you think would happen? What has the greatest effect? Now take a look at these predictions. On the left side are the scenarios, and you can see on the top we have the incidences of heart disease, total heart attacks, incidence of stroke, and death from any cause. Notice the parentheses next to the projections. That's the percentage reduction in these events compared to what's expected. Now look at the 3 grams per day reduction in salt. This would be expected to result in 66 to 110,000 fewer incidences of heart disease, up to 58,000 and 92,000 heart attacks per year, same as cutting smoking in half. Strokes would drop by 5 to 7.8%, and between 51,000 and 81,000 people wouldn't die in a year when they otherwise would. Even reducing salt by 1 gram per day was shown to reduce these by a few percentage points. Now, the recommended intake of salt is 5.8 grams per day. That's the 2,300 milligrams of sodium, with a more ideal recommendation of 3.7 grams per day. Now, our average salt consumption in men is 10.4 grams, and in women, 7.3. And this means that the reductions in salt intake described by this study would still result in many of us being well over the recommended amounts. It makes this seem very attainable, but it's only attainable if industries cut it down. We can't rely on consumers to do this on our own just by knowing better. So the Institute of Medicine called for the government to set limits on the amount of salt in processed foods. A food regulation, the FDA has turned into guidelines for food companies. In May of 2016, they set 2-year and 10-year goals with the goal of cutting 1,000 milligrams of sodium a day from the American diet. And that would be about 2.5 grams of salt. Of course, the Salt Institute and food industries are claiming that this is government overreach and that it's impossible to reformulate almost every food product on the shelves. So we'll see how this prevails, but it looks like we're headed in the right direction. When we evolved, we were eating 10 times as much potassium as sodium. Today, we consume about 3 times as much sodium as potassium. Now consider that sodium directly leads to increased blood pressure and heart disease risk, while potassium helps to relax the arteries and lower blood pressure and lower heart disease risk. Yes, we know that high sodium equates to increased risk of death. This study showed a 20% increased risk of death from any cause compared to people with lower rates of sodium intake. A similar but inverse trend was found with potassium, with 20% lower risk of dying if consumed higher amounts compared to lower amounts. But the interesting thing with this study was the fact that the ratio between sodium and potassium intake might be what's even more important. People with the highest ratio of sodium to potassium doubled their risk of dying from a heart attack and had a 50% greater risk of death from any cause. This means that we need to eat more potassium-rich foods like beans, and sweet potatoes, and greens, plants in general, and cut down on the high-sodium products like bread and cheese and processed meats and processed foods overall. We'll move on to chloride. We use chloride to maintain our fluid balance and create hydrochloric acid in the stomach. Since it's the other 60% of salt, most of us consume too much. Our kidneys do a pretty good job of excreting excess chloride, and deficiencies are rare, but if we vomit a lot, then we are at risk of losing more chloride by needing to consistently replenish the hydrochloric acid that's lost. And calcium, it's the most abundant mineral in our bodies, making up 1.5 to 2% of our body weight, mostly in our bones and teeth. We need more as we're developing, and then the recommendation settles down to about a gram per day. And when we have a dip in calcium levels, our bodies will demineralize bone to make up for it, but we'll also absorb more in the small intestine, and we'll excrete less in the kidneys to retain what we have. Our absorption rate of calcium is typically only around 25 to 35%. We talked about some reasons why before with phytates, competition from other minerals, and oxalates, but calcium depends on vitamin D for absorption, so calcium absorption drops dramatically if vitamin D status is low. Calcium supplements are often combined with vitamin D because of this, and dairy has both. You may hear that because of acidic proteins in dairy that you can actually have a greater bone degradation, but at this point it doesn't appear to be the case. Dairy still increases bone growth and typically lowers the risk for fractures. You'll just get a lot more healthy phytonutrients and potassium if you have a greater reliance on calcium intake from plant-based sources. Our bones also hold a lot of magnesium. About half of the total magnesium in the body is in the bones. And this is used as a cofactor as well in more than 300 enzymatic reactions, including on myosin ATPase for muscle contraction for you exercise physiology majors. The whole grains and vegetables are a great way to get them in the diet, and because of it, only about 3/4 of Americans get these recommended amounts that are shown in the chart. Sulfur, it doesn't act alone like other minerals. It's a component of certain amino acids and B vitamins, and it helps with liver function and acid-base balance. We typically get enough of it in our diet, so we'll move on to the next slide. So let's go to the trace minerals. Now, iron deficiency is the most common nutrient deficiency in the world, with 43% of children 5 and under and 38% of pregnant women globally not getting enough. And this can lead to deaths of both the baby and the mother, but it's not just in developing nations. It's the only nutrient deficiency prevalent in industrialized countries as well. We rely on iron to attract oxygen on hemoglobin molecules so we can carry it to the tissues. In fact, most of your body's 2 to 4 grams of iron is found in hemoglobin. It's also involved with the immune system and for brain development. And children with low iron status have impaired intellectual development. And this is thought to have to do with iron's role in providing the myelin sheath and helping produce the myelin sheath around axons, which allows for a faster communication between neurons. And it's also involved in producing neurotransmitters as well. But the last thing about iron is the absorption. And absorption rates can be less than 1% or over 50%. It's a big range, and it tends to correspond with how badly your body needs it. For example, men absorb about 6%, while women absorb 13%. And that's in order to make up for the lost iron during menstruation. Stomach acid is also necessary, and since older adults produce less stomach acid, they're at risk for low iron absorption. And they also like to pop antacids, which can reduce, obviously, stomach acidity and iron absorption as well. Heme iron from hemoglobin or myoglobin in animal foods is more efficiently absorbed than non-heme iron found in plant foods. But pair iron with vitamin C with your non-heme spinach, and you can increase your absorption rate by 300%. On the other hand, phytates and whole grains and polyphenols in coffee and calcium supplements, it all can inhibit your iron absorption. So zinc deficiency was only noticed in 1961, so it's as old as the Minnesota Vikings. Zinc has all sorts of functions, but they fall into categories of catalytic as a cofactor in about 100 enzymes, structural, helping to fold proteins properly, and regulatory, helping to control gene expression at the site of DNA, cell death as well, and even nerve transmission. Move on to selenium. It functions in antioxidant systems and is a bit of a tag team partner with vitamin E as they share similar roles as antioxidants. When one is reduced, the other can pick up the slack. We need about 55 micrograms a day of selenium, and our diets typically provide that. So let's move on to iodine. It is so critical to brain development that salt iodization has led to an increase in IQ points. Iodine deficiency can result in goiters as the thyroid gland is overstimulated. And overall, the iodizing of salt has been really successful. So I suppose there's one good thing with the high salt intake. It could be used to smuggle in some iodine. And our final five, copper. It's a component of many enzymes and necessary for collagen synthesis. So be sure to consume copper-rich foods when you're recovering from injury or surgery. Both deficiency and toxicity are rare. So let's move on to fluoride. Fluoride conversation centers around our teeth. Too little and we have tooth decay, too much and we have fluorosis, which weakens the teeth, and we can have brownish stains all over our teeth. In addition, we can have stomach inflammation and fractures with too high amounts. And because of this delicate balance, there's always a debate over how much fluoride we should be putting in our public drinking water. Chromium appears to enhance insulin sensitivity, yay for chromium, and it maintains blood glucose levels by doing so. However, toxicity and deficiency are rare. Manganese is involved in energy metabolism and is a component in enzymes like superoxide dismutase, a key antioxidant enzyme. And molybdenum is found in a normal diet, and it functions as a cofactor mainly in amino acid catabolism. So to review, the key roles that these minerals play are as cofactors, and think of this as complementary, where they modulate the enzyme activity, or they can be coenzymes where they play more of an active role in a reaction. They can modulate genetic control by binding to DNA and regulating production of new proteins and receptors. And they play critical roles as antioxidants. Now, free radicals are oxygens that end up going through the mitochondria's electron transport chain. And instead of picking up two hydrogens and becoming water, they have unpaired electrons. And this makes them highly reactive, and they can lead to oxidative stress, known to damage components of the cell, damage the DNA, and damage the overall efficiency of energy production. So we talked about vitamins A and C and E being potent antioxidants in their own right, and then the enzyme systems like superoxide dismutase and glutathione peroxidase that are comprised of some of these minerals. They all function to reduce these reactive oxygen species, which to me is a more fun term for free radicals. There's lots of really cool research on this. And before I end, I want to share a few studies. This one is on the length of our telomeres, those caps at the ends of our DNA that shrink as we age. And this study found that when you're young and you consume vitamin C, folate, and potassium, you can delay biological aging as an older adult. And this study says, well, if micronutrients function to improve oxidative stress and inflammation, are rates of consumption different in those with metabolic syndrome, which is characterized by greater oxidative stress and inflammation? And these researchers surveyed a few thousand people with a 24-hour dietary recall, and they compared those with metabolic syndrome to those without metabolic syndrome, and found that the groups consumed equal amounts of the assessed micronutrients. They found that micronutrients uh, they didn't appear to influence metabolic syndrome. But then this study came out and used some stronger methods of dietary assessment in a 3-day dietary record and a food frequency questionnaire. They ended up finding a significant positive association between the dietary total antioxidant capacity and the intake of fiber and folic acid, vitamin A, vitamin C, magnesium, selenium, and zinc. And the more total antioxidants you had, the better your blood pressure, better your glucose levels and free fatty acids. So, according to this study, we do rely on micronutrients to hold off metabolic syndrome and the chronic diseases that it creates.